Moving right along, Unit 7, trig. First thing you could write down is SOHCAHTOA. If you get that locked in, you should be good to go. So this says, given cosine is this in quadrant 1, so they're trying to give you a picture. Every picture tells a story. Cosine is adjacent over hypotenuse, so they're saying, hey, that's your adjacent side, which remember, that's your x-axis whenever you're talking adjacent. And that right there is your hypotenuse. Remember, your hypotenuse is always positive. So we're going to try to draw this somewhat proportionately. That's 35. And then my hypotenuse is 37. Wait a minute. Shouldn't look like that. It should look more like that. Kind of close. Let's make this 35, and then this is 37. I'm going to move this. Information's getting overloaded. 35. There. So my spinner, my hypotenuse, needs to look the same-ish as my adjacent side. I just wanted to have it look somewhat right. So it says, what are the other trigonometric ratios for theta? Well, theta, remember, is your reference angle. It's down here. So that's telling you got to find the opposite side, which is x. Well, we got to use, there's no family here, so Pythagorean theorem, a squared plus b squared equals c squared. And if we do the math there, and here we go, 37 squared is 1,369. X squared, what is 35 squared? 1225. So 1369 minus 1225 is a nice, neat 144. Bada boom, bada bing. You don't have to do the right thing because we don't need a negative side. So x is 12. So there's my picture. Every picture tells a story. So what is sine? Well, sine of that would be opposite over hypotenuse. Remember, the reciprocal function is cosecant. So we're just going to flip that. And cosine, well, they already told us cosine is 35 over 37. So its reciprocal of that is secant. Flip it, 37 over 35. Tangent, well, that's opposite over adjacent, so that's 12 over 35. No square roots, which is nice. We don't have to worry about clearing out the denominator. Cotangent, flip that, 35 twelfths. A lot of work, a lot of little parts, but there's the big picture. So the sun is shining and creates a 27-degree angle to the ground, to the ground, to the ground. Can't emphasize that enough. So here's the sun, and it's creating this, and here's the ground. So there's the 27. A lot of students put it up here. Eliza's head is casting a 120-inch shadow. So here's Eliza, which means this is Eliza's shadow, 120 inches. And basically that's a fancy way of just, sorry Eliza, building a right triangle. So it says, how tall is she? Well, that's x. Well, if this is my reference angle, that makes this my opposite side. We know this is the hypotenuse from here to here. And then this means that's my adjacent side. So what am I going to use if I need my opposite side involved and my adjacent side involved? Tangent of 27. So tangent of 27 degrees is equal to opposite over adjacent. Now a very, very important part. Hit mode. See that right there? I didn't even try to do that. My other classes use radians for pre-calc a lot. So somebody highlighted radians. So go over there, highlight degrees. Now my calculator will work properly. Tangent of 27, enter, is 0.509 equals x over 120. So I'm going to multiply by 120, multiply that by 120 to find x. and I get 61.14 inches. So there you go. Alright, a lot of confusion on this problem when they say find the exact value. Yes, you could take your calculator and just go tangent of 30 and then put 0.577. It seems like that's your exact answer. That is not what they're asking for. You're not wrong, but they want you to show that you understand trig. So it's all about the spinner. In other words, you take your spinner, you flip it 30 degrees, so your spinner starts here, just always does. Flip it up 30, build your triangle, recognize it's a 30, 60, 90, so you can build your own 30, 60, 90 if you follow the rules. I'm going to make it easy. If that's 1, this is 2. If that's 1, this is the square root of 3. What's tangent? Opposite over adjacent. Opposite over adjacent. So it's 1 over the square root of 3. Got to get that square root out of there. So I get the square root of 3 over 3. There's my answer. If I hammer this out on a calculator, guess what? You're going to get 0.577. But this is what they want when they say find the exact value. It is not a calculator problem. You can check your answer with your calculator. You got to show your work, even on your exam. Cosine of 45. Well, we take our spinner. We don't know how long it is. We can make up our dimensions in a minute. Flip it up 45 degrees. So there's 45 degrees. Create your triangle. Don't ever come back to the X or the Y. So we know this is X. We know this is X. We know this is X squared root of 2 based on our 45, 45, 90 rules. I'm just going to make this a 1, making this a 1. Making this 1 square root of 2, which is just the same thing as saying the square root of 2. Well, what's cosine? Cosine is adjacent over hypotenuse. What's this thing over, whoopsie, this thing? It's 1 over the square root of 2. Get that out of there. Square root of 2 over 2. That's what you're going to be looking for. So, I'm hoping these are multiple choice questions, so then they won't give you any of these decimal answers. So I don't know how you're going to work that out, but I'm going to check your work. Make sure you did it. Sine of 120. There's my spinner. 120. 90. Why'd I go up? Because this is positive. Plus 30. You got to be careful there. Make it look somewhat realistic. It's going to help your brain. How do I build my triangle? Do I ever go back to my Y? No way. Back to your X. Making this 60, 90, and that's 30. So I'm focusing on this triangle. There are no dimensions, so I'm going to make it easy as possible. I'll make that a 1, but be careful, that's negative 1 because it's left. This is up, so it's positive, but I got to multiply that by the square root of 3, and there's my hypotenuse. So what's sine? Opposite over hypotenuse, square root of 3 over 2. Number 25, an angle has a reference angle. Remember what that means. It's sandwiched between the x-axis and the spinner of 37 degrees, and its terminal side lies in quadrant 2. Get a picture. So here's quadrant 1, here's quadrant 2. Reference angle 37 is going to be something like this. It says, what is one positive and one negative coterminal angle? Well, to go positive, keep that pink, you'd have to go right here, which is really 180 minus 37, so 143. There's my positive coterminal angle that stops right there. Negative, we're just going to go start here and go down and have it stop right here as well. Well, that would be the negative one. Remember, is down. It'd be negative 180 plus another negative 37, which is negative 217. Would land me right there. Okay, moving right along. Find the 5 remaining trigonometric functions if cosecant, so remember what cosecant is, it's reciprocal of sine. If you get off to that start, that's good. So remember, sine is opposite over hypotenuse, and the hypotenuse is always positive. So I'm talking about this negative. What do? Do I bring that negative 13 with it? I wouldn't. I'd keep the negative with the 5. And this helps me really get a good picture of what's going on. So it says third quadrant. I never got to that. But here's quadrant 1. Not talking about that, not talking about that, not talking about that. How do we build a picture where the opposite's negative 5 and the hypotenuse is 13? It's going to look something like this. Notice that's negative. It all seems to make sense. That's a 5, 12, 13, but that needs to be negative. Don't forget it. Here's my reference angle, so now I can find anything. Well, cosecant is this. Sine is this. So now we're going to find cosine of this situation, which is adjacent over hypotenuse. That's negative 12 13ths. Which means secant is the reciprocal of that. And typically they just leave the negative in the top. They are not saying the hypotenuse just magically became negative. They're not saying that. They're just keeping the negative in the top. Tangent of theta is opposite over adjacent, so that's this over this. A negative divided by negative is positive. And then if you flip that, you get 12/5. So there's the trigonometric functions. 27. The sun is shining and creates a 22 degree angle to the ground from Elmer's head. So we're going to, this time we're going to go like this. Sun, here's Elmer's head. Somebody did call me Elmer Fudd this year. I'm a little offended by that. So there's the 22 degree angle to the ground. Some students put it here for some reason. I guess that's going to the ground, but they're saying with the ground, kind of like with the ground. The ground and that sun ray form the angle. So maybe you just need it said differently. So here's my 90, and it says, which is 72 inches from the ground, so that's 72 inches. It says, how long is Elmer's shadow? This time they're asking us to find that. Well, if that's my reference angle, here's my opposite side. Here's my adjacent side. From here to here is my hypotenuse, and we're not using that. So what uses opposite and adjacent? Well, that's classic TOA. So I'm going to take tangent of 22 degrees, and I'm going to go opposite over adjacent. Now notice they wanted to create a problem where the variable's been dumped in the denominator. Don't panic. Let's go tangent of 22 degrees. Don't forget mode 0.404. So this is 0.404 equals 72 over x. Now I'm sure different people have different ways of doing this, but I'm going to multiply by x. And I'm going to multiply by x. So 0.404x equals 72. So I got to divide both sides by 0.404, and I can see what x is. X is going to be this when I'm done calculating it. So 72 divided by 0.404. Approximately 178.21 inches, because everything's in inches. Alright, that finishes chapter 7. That went fast. So we'll see you for chapter 9 in a few moments.